Okay, this will be a shorter video. And yes, I did assign 2 videos to be watched on the same day. Normally, this is an extra video that I ask my students to watch. It is lecture material. I will show some of my bad statistics in this video because the one thing that I don't get to do as much when we're not in the classroom is show that to you. But first, if you have not done the dentist brushing teeth box plot, I want you to pause this video and go practice that. Hopefully you did it, you checked the answer key, and everything is good. But if not, here is the answer key. And I just want to point out a couple of things, even if you got it right. So this was how long, I think there were 20 people who brushed their teeth. I guess it was handout 1. It's a pretty basic box plot, right? You have one outlier. Didn't have any low outliers, so you didn't have to check that extra fence down there. The median was left of center. The right whisker is 45, the left whisker is 15. So the right whisker is longer, and there is an outlier, and it's on the high end. So this is a great example of where all 3 clues for how to tell skew of a box plot, they all say the same thing. So this would be an example of something I would ask you on a test, and this one is indicating right skew. Some other things as part of that handout, I think it asked for either the 25th percentile. Remember, that's a synonym for Q1. It would be 30. Not sure if it asked the 50th percentile, but that would be the median, 45. I do know it asked this. Part A, I think it asked for sample mean, which would have been the very first entry in your output screen, right? And then it says pretend these times are a population. What's the population mean? Well, technically the population mean is mu, but you're never going to find that on your TI-83 output. If you look back at the notes for mean and median, we were talking about for one particular given data set, it's the same formula for the sample mean and the population mean. You add them all up, divide by how many. So it's the same answer. It's the exact same number, okay? But it's really just a matter of how I'm referencing you for one particular given data set. Now, in real life, it's a completely different story. You know, what is the true mean SAT score for JMU students? I have no idea what that is, but I could go get various samples, calculate all these different X bars, and let them help me estimate that unknown mu. But that's not what I'm talking about here. For the dentist handout, I gave you a data set. So if we were viewing that as a sample of tons of human beings, it would be X bar. If we were viewing it as the only 20 people I cared about, we would be viewing it as a mu. And that's why you'll see my particular wording. Pretend this is a population. What's the population mean? So they would be equal for the same data set. Okay. Now, what's interesting is there's another 2 pieces on that dentist handout, and it asks you for sample standard deviation, and it asks you for population standard deviation. And I may have mentioned in the last video where to find that on your calculator screen, but here's the video that actually talks about those 2, and it turns out that those 2 are very different formulas, so they are different answers. All right. Good news for all of this. Even though I'm about to show you some formulas, again, we get the standard deviation off of our calculator, particularly if you came out of AP Stats or one of my colleagues. You may have been forced to calculate standard deviations by hand. Please know you are not doing that for me. It would take way too much time. There's really nothing productive in doing it by hand. That's what we have our calculators or computers for. So, last time we did the measure variation, the IQR that goes with the median. Today we're doing standard deviation that goes with the mean. Okay, let me write up some stuff and then we'll talk about it. It's not very pretty. Okay, so just like with the mean, we have sample and population notation. Sample standard deviation is denoted by S. Your calculator makes it a capital S. It should be a small s. It doesn't really matter though. Population standard deviation is sigma, the Greek symbol, kind of like an O with an extra little line at the top. Again, TI-83 makes it sigma x. That little sub x is not that important. Just don't let that throw you. In general, a quick little definition is standard deviation is the average or typical amount a data point is away from the mean. Now, this is more one of those almost like Where's Waldo or notice the difference in two pictures. These formulas look pretty similar. But let's look at them a little bit closer to see what's different. Well, visually, I'm just visually looking to see. We have that and we have that, right? And that is the correct notation. If we're in sample, we're talking about the sample mean. If we're in population, we're talking about the population mean. But as we just talked about and had talked about when we did the mean notation a few videos ago, for one given data set, they're going to be the same number. So really that's just a notational difference. There's nothing different in the quantity there, okay? I am noticing a square, and remember that's the summation sign. Now what really is different, this is dividing by n, n minus 1, that's dividing by n. So that right there tells you these quantities are going to be different, and that is why you'll see two different numbers when you look at your TI-83 for any given data set. I really want to talk about this one. This one probably makes the most sense because I'm going to draw a picture in just a second, but you can kind of see I'm adding something up and dividing by n. That kind of seems like an average, right? And here we say standard deviation is the average. So I can kind of see, add them up, divide by how many. I'm still real confused with the square and square root, but we'll talk about that in a minute also. Do know, though, that that square root and that square cannot cancel if for no other reason the n does not have a square on it. Then what's up with this one, though? Just briefly, and we're not going to get into the theory and the history of it, but we take samples to let them help us estimate the population that we don't know what it is, right? And through research, they have found historically that if they divided the formula for the samples by n minus 1, it gave a better estimate for the population. So, that's probably the easiest way to think about it. I'm probably going to rewrite this, but then I want to draw a picture. Just, again, you're not going to be working that formula by hand, but I'd like to give you a 4-minute background of what the heck that formula is and why does it even measure something we call variation. So that's the formula I just want to talk about. In some sense, you really don't have to draw this. Here's a unimodal and symmetric. Why? Because the mean is only good for unimodal and symmetric, right? And here's your mu, okay? Now, there's lots of data points here. Here's one data point. that's a little above the mean. Here's one that's way above the mean. Here's one that's a medium amount below the mean. Here's a data point that's, way far below the mean. Here's one that's, kind of close to the mean, below the mean, right? Here's one that's a little bit above the mean. See all these lines that I just drew? How far a data point is away from the mean. Distance, right? This distance, that distance, that distance. That's what this x minus mu is. How far is the data point, the x, from the mu? Now, I have used the correct word, distance, but really that would be an absolute value. See, this is positives, because these x's are bigger than the mu, but these would be negatives. If you add up positives and negative numbers together, they would actually go to 0. Well, this curve has spread. I see it spread out. The spread's not 0. So while it probably makes a lot more intuitive sense to say, oh, just take the absolute value, for theoretical reasons that we are not going to talk about in Math 220, we don't take absolute values in stats. We square things when we don't want them to cancel out. Sorry, you can't see my little square. Okay, so really, we're squaring all of these differences or distances just so they stay positive, okay, instead of absolute value. Again, I know that probably doesn't make sense to y'all, but just trust me. You should at least know that when you square something, it keeps everything positive. Okay, so I'm going to add up all of these squared differences and divide by how many. So you can kind of see that average coming out. But the problem is when I squared them, it really blew them up, right? Made them a whole lot bigger. So at the very end, I take the square root just to try to bring it back down. But again, that square root and that square are not completely canceling each other out. Particularly if you're a science major, I know they're very picky on you always writing the units of a problem. So think about if this were in inches. Okay, let's say that's 4 inches. Then I square it. I'm up to 16 inches squared. So I would add all of this up, divide by how many. I would still be at inches squared. But then when I take the square root, at least I'm back down to the original unit of inches. But just maybe the picture will help you say, what the heck is that formula calculating? Why is it calculating spread, right? Because I can see my curve is spread out. A curve that doesn't have as much spread, you would have seen in the last video, would be something like this, right? Those distances are much smaller on average than my black and red curve. All right, but again, standard deviations be part of our entire course, but again, you are not calculating it by hand. If you're given a data set, you will be using your calculator. Future sections and chapters, pretty much standard deviation is just given to you and we use them in word problems. I want to take a few minutes, and I know I run the risk of you guys cutting off the video, but I really would appreciate if you hang on for 5 or 10 minutes, because this is the stuff, while it's still not as much fun on video as it is in the classroom, this is actually the stuff that my students mention on the end of the year evaluations every single semester. That the idea that I try to make it very real life, I collect all these bad statistics stuff that comes into my life. I don't go to the internet and look for it. It just comes to me, right? So I just want to show you a couple of them. I know I already showed some bad bar charts when we were doing that. Let me find, particularly in case you give up on me after a minute or two, I want to find probably the most important one I will ever tell my students, and it actually relates to you guys. So if we were in the classroom, I actually would ask you guys to raise your hand if you've ever heard this. It's not a pleasant topic, but unfortunately it's real. If you're ever being abducted, kidnapped, and they want to take you to the ATM and make you, take money out, that if you put your PIN in backwards, it will alert the police. Usually I have about 10% of my students raise their hand that they've actually heard this. You know, anything on Facebook, they're lies, they're urban myths, they're whatever, right? They're not correct. Usually will circulate every couple of years. And I, of course, have fellow moms as my friends on Facebook, and they believe this. So usually it's some form of this. ATM PIN number reversal. Good to know. And it tells you, now first of all, if you read it really carefully, which you don't have to do right now, there's usually some misspelling, which is a really good tip that an article is not real, right? But it says the ATM system recognizes that your PIN is backwards from the card that you put in there, and the machine will still give you money, but unknown to the robber, the police will immediately be dispatched to your location. This is absolutely false. I mean, there's so many issues with it. What about if your PIN was a palindrome? I think that's the word, forwards and backwards. When my friends, Facebook friends, show me they're idiots, I don't normally ever say anything, right? On this one I did. I've crossed out the person's name, but you can see that I tried to link that this is a false statement, and all my quote-unquote friend did was say, "Thanks for the update." What I wanted them to do was delete it, because I have seen my fellow moms actually discuss this. And one time, one of the moms said, "Oh, thank you for posting this. My daughter is going to college next semester. I'll have to make sure I tell her." Parents think this is true, and it's a line of defense. Any police officer or whoever will tell you there's a very small window of opportunity to get away from an abductor. And if you just go along with them because you think you're going to be able to, get the police to come help you, the police are never, ever coming. Think about the logistics. This was when I did research for about, 45 minutes one day. Obviously with technology, the technology is there and it exists. But think about the logistics of implementing that into every single ATM at every single bank, to every single police station, sheriff's office, etc. It's never going to happen. So this is why when I find things that are fake news, and I do not mean politics, on my Facebook, I will always cut it out and bring it in, because it really can be dangerous if people are gullible and believe everything. Just another one, just about understanding mathematics. So I want you to just look at that title. Home births in the U.S. increase 20%. Okay. Now I'm kind of interested in the topic of home births. I had my 4 daughters in the hospital, but I know a lot of moms. And given that I'm interested, and I do know a lot of moms, I'm not even sure if I know one who had their baby at home. But this makes it seem like it's such a big amount. Here's the problem. First of all, this article was done well. It gave an awful lot of fractions and awkward numbers. So here's my fear, that the general public is never going to be able to read through this entire article. And then within a week, they're going to just say to their friend, I was reading something about home births in the newspaper the other day. I think it said that 20% of moms have their babies at home. That's not what that said at all anyway. But if you get overwhelmed in numbers when you're reading an article, you're going to completely change what the article was about. Where do they even get their increase 20%? It's not a lie. It's just misleading. They break it down by race and all these different things. I just want the races combined. 1 in 143. This was in 2008. And then in 2004, apparently it had been 1 in 179. Terrible, awkward fractions, right? I can't even wrap my mind around those numbers. And here's good practice for something that students continue to mess up on my final exam. Okay, we have decimals. If you're going to turn that into a percent, This is 0.56%. This is 0.7%. This is not 56%. This is not 5.6%. That's not 70%. That's not 7%. Particularly for my class, you have to be able to take tiny percents and go backwards to the decimal. So if I just lost you right here, you need to pause and rewatch this, because on every single test and exam that I give, I have students who cannot turn a percent into the decimal correctly. Okay, so if you know you're weak on that, you need to practice it. But back to this thing. Both are still less than 1%. It went from a little over 0.5% to about 0.7%. But guess what? That is a 20% increase. But the base rate is still below 1%. So that's pretty misleading. Newspapers love to do capture headlines, right, to suck you in. But the problem is the general public cannot wrap their minds around these numbers, so I'm afraid they're going to start saying, oh, 20% of babies are born at home, which is not at all what this article said. Another one, I have magazines to help me fall asleep at night, so magazines that are really geared towards what I call the general public. This was from Women's Day. Says no tan is a safe tan. Okay, so first of all, you shouldn't be going in a tanning bed, but that's not why I'm showing this to you. And you probably can't even read that, so let me read it to you. No tan is a safe tan unless it comes from a bottle. Your risk of cancer, now I'm going to write down what they say, goes up 15% for every 4 times you use a tanning bed. And it says that's what Brigham and Women's Hospital and Harvard Med School came up with. So, first of all, I am not picking on Brigham and Women or Harvard Med School, because here's the problem. I don't think that's what they said. I think whoever went to the original journal entry tried to paraphrase this, the editors of Women's Day, and I don't think they paraphrased it correctly. Because, I mean, they haven't given me enough anyway, but goes up 15% for every 4 times? Well, first of all, 4 times what? In my entire life? Or do you mean 4 times in a week? 4 times in a day? How long? Do you mean if I'm in there 8 minutes or 20 minutes? There's so much wrong with this, right? 15% for every 4 times. Does that mean after like 24 times, I have a 100% chance of getting cancer, skin cancer? No, that's not the case either. So basically, this is just a bunch of mumbo jumbo that means nothing. Maybe I shouldn't complain, because if it scares people from using a tanning bed, even better. But see, that's the problem. We cannot use bad statistics just to get people to do what we want them to do, whether it's good for them or not. I'm always about presenting information accurately, correctly, truthfully, and then letting the consumer of the information do with it what they will. So even though I do think tanning is bad for you, this is not a correct paraphrasing of the risk. Let me see if maybe I'll show you just one more. So hang in there with me. I promise I'll keep it to just one more. Oh yes, we'll cut to this one. Here was the title. I had to find the Word document because the newspaper copy would not copy very well anymore. Sexting numbers among teens lower than thought. This was, I remember this specifically because it was in my local newspaper. And the problem is I was reading the article and, you know, they were really presenting the information very well. They were using percents instead of like awkward fractions. They were even defining what they meant by sexting, that type of thing. So then I thought, well, let me cut this out and bring it to class to show people, you know, how they are at least presenting the material well. Well, the article was on 2 different pages, so I had to flip through the newspaper to try to find where the second part of the article was, right? And the title, while I was flipping through, the title kept getting in my head. Sexting numbers among teens lower than thought. As if I had a thought. Like, as if they had told me a week ago it was really high and now they've come back. And I had never even ever read an article. So I'm like, oh, I wonder what article I missed last year where they told me it was high. I don't know. So I finally find the end. So let's see. This says 2.5%. So this is sexting topic. The topic is really important here. Ages 10 to 17. I finally get to the end. And apparently in 2008, they had scared all the parents. They had said, it says, released a widely cited online survey. I never read it, but they had said that 20% ages 13 to 19 had been sexting. So apparently, a few years previous, they had really scared all the parents. So then this new article comes out, and it's like among teens lower than thought. Okay? And apparently now it's just 2.5%. Well, that is a massive decrease, right? How do we go from 20% to 2.5%? Look at it. So this is very common in an intro to psych course. You can usually pull out journal entries and kind of pick on them about who they studied, that type of thing. Look right here. Think about this for a minute. This is not about drinking Coca-Cola or drinking Mountain Dew or watching TV. This is about sexting. Look who was included originally and who's included now. Basically, they got rid of the 18 and 19-year-olds, and who did they put in instead? The 10, 11, and the 12-year-olds. Okay, sorry. As a mom, of course, we will always view our even adult children as kids. But guess what? 18 and 19-year-olds are not children. They are adults. I'm not sure why they were ever involved in this study. But they just took out basically adults and replaced them with 10, 11, and 12-year-olds, and they're finding it fascinating that it decreased. Well, of course it did. You have to, particularly on this topic, you have to use the same age group. I don't know why they just didn't, do the 13, well, I'm sorry, well, they would have needed to have done the 13 through 19, so maybe they could have gone back here and picked out, each one like 13 to 17 or something. But this is a big old mess. So for an article that I was going to bring in as being well written, now is one of the worst articles I've ever seen. Because there's a couple things that go into sexting. Obviously, access to a phone, and I know that even most 11-year-olds have iPhones now, but still, there are still some parents who try to hold out at the 10 and 11-year-old mark. And there is a thing called puberty that does tend to encourage sexting, right? But again, you cannot replace 18 and 19-year-olds with 10, 11, and 12-year-olds and think that that is a valid comparison of, data analysis from two different studies. This is really, really, really bad. So keep your eye out for different things like that. So many of my articles, again, come from the local newspaper, from my Facebook newsfeed, from radio, from the Breeze newspaper, from, at different colleges, things that I see on the, bathroom stalls at colleges. And then, of course, some of my pitiful, very easy to read magazines that help me fall asleep. So all of this stuff is critical thinking. No, do you have to go through Math 220 to understand this stuff? Absolutely not. But so many people just believe every single thing that they read and hear, and they continue to share it. And it's even gotten worse now that it's hit the political scene and other important topics. But even for those little things that come through our life, always think and read and question everything. And usually within 5 minutes, you can make sense of it. All right, that is it for this topic in this video.